Network traffic analysis, NTA, is a critical skill in cybersecurity that allows security professionals to monitor, detect, and analyze network activity to identify malicious behavior. Cyber threats are constantly evolving, and attackers frequently exploit network vulnerabilities to gain unauthorized access, steal sensitive data, and disrupt operations. By closely examining network traffic, analysts can spot unusual patterns, unauthorized access attempts, and data exfiltration before they escalate into full-blown attacks. In this lesson, we will explore the fundamentals of network traffic analysis, including different types of network traffic, common attack patterns, essential tools used for network monitoring, and key defensive strategies to strengthen network security. Network traffic refers to the data packets transmitted between devices over a network, whether within an internal system or across the internet. Every piece of information exchanged online, from sending emails to loading web pages, is composed of network traffic. Understanding the different types of traffic and communication protocols is fundamental to recognizing suspicious activities. Some of the most commonly used network protocols include HTTP/HTTPS, DNS, SMTP, TCP, UDP, and ICMP. Attackers often manipulate these protocols to bypass security measures or hide their activities within legitimate traffic. For instance, malware frequently disguises itself as normal HTTPS traffic to evade detection, while attackers use DNS tunneling to smuggle malicious payloads past firewalls. Without proper monitoring, these covert attacks can go unnoticed for weeks or even months. Cybercriminals leverage various attack techniques to exploit network traffic vulnerabilities. Port scanning and reconnaissance attacks are commonly used in the early stages of cyber intrusions, where attackers probe network systems to identify open ports and services that may be vulnerable. Once they gather this intelligence, they can deploy brute force attacks, malware infections, or remote exploits to gain unauthorized access. Another major concern is command and control, C2, communication, where malware on an infected system secretly sends data to an external attacker-controlled server. This can result in data theft, ransomware activation, or remote code execution. Similarly, denial of service, DOS, and distributed denial of service attacks flood network systems with excessive traffic, causing severe disruptions and rendering services unavailable. Attackers also use packet sniffing to intercept unencrypted data in transit, allowing them to steal login credentials and sensitive financial information. These are just a few examples of how malicious network activity can severely impact an organization if not properly monitored and mitigated. To effectively analyze network traffic, cybersecurity professionals rely on specialized tools and techniques. One of the most widely used tools is Wireshark, an open-source packet analyzer that provides deep insights into network communication by capturing and inspecting individual packets. Zeek, formerly Bro, is another powerful tool that enables real-time network monitoring and intrusion detection. Organizations also deploy intrusion detection and prevention systems, IDS/IPS, such as Snort and Suricata, which automatically detect and block suspicious network behavior. NetFlow and SFlow are commonly used for traffic flow analysis, allowing analysts to visualize network activity and detect unusual spikes in data transfer. Security Information and Event Management, SIEM. Systems integrate multiple security logs and correlate network events to identify patterns of potential cyber threats. By using these tools in combination, security teams can gain full visibility into network activity and proactively respond to security incidents. To enhance network security, organizations must implement proactive defense strategies against network-based attacks. One of the most effective measures is network segmentation, which involves dividing a network into isolated sections to prevent attackers from moving laterally if they breach one segment. Access control lists, ACLs, and firewall rules should be strictly enforced to filter traffic and block unauthorized connections. Organizations should also implement multi-factor authentication, MFA, and strict user access controls to reduce the risk of credential-based attacks. Encrypting sensitive network traffic using TLS, SSL protocols ensures that intercepted data remains unreadable to attackers. Additionally, continuous network monitoring, anomaly detection, and log analysis should be prioritized to detect potential threats in real time. Regular penetration testing and vulnerability assessments can help identify security gaps and ensure that defenses remain strong against evolving attack techniques. In conclusion, network traffic analysis is a vital component of modern cybersecurity, enabling organizations to detect, prevent, and respond to malicious activity before significant damage occurs. By understanding network protocols, identifying common attack patterns, leveraging security tools, and implementing proactive defense mechanisms, security teams can significantly reduce their exposure to cyber threats. In the next section, we will explore real-world case studies where network traffic analysis played a key role in stopping cyber attacks, demonstrating its importance in safeguarding critical systems and data. Stay tuned.